Polynomial application problems. So I'm going to do an example here with the package. It says a package can be sent by mail only if the sum of its height and perimeter of the base is not more than 80 inches. Find the dimensions of the box of maximum volume that can be sent if the base of the box is a rectangle whose length is 2 times the width. Draw a picture, find the function, and sketch the graph. What is the maximum volume? What are the dimensions of that box? So the first thing you need to do is make sure that you understand what the question's asking for. They're asking for the maximum volume, and they're also asking for the dimensions. And dimensions, of course, means the length, width, and the height. So the best thing for me to do first is I'm going to draw myself a picture. So it's a package that has a rectangle as the base. So I'm going to draw a rectangle as the base. And it's going to be a three-dimensional box. So I'm going to make my box here. And what they tell me about this box is about the base. They told me that the base of it was, the length was 2 times the width. So I'm going to label my width here W, and this side will be 2W. So if I want to find the volume, since that's what they're asking from me is for the maximum volume, I need to find out what the height is. So I go back up in the problem, what they told me about the height. Well, the sum of the height and perimeter is not more than 80. So the height plus the perimeter, what's the perimeter of my base? 2W plus 2W plus W plus W, so it's 6W. And it's not more than 80, so I'm going to put 80 since that's the maximum that I can have. So the height in terms of W would be 80 minus 6W. If I want to write a function, I need to have just one variable here so that I can write my function rule. So now I have this whole thing in terms of W. So now, since I'm trying to find the volume and the variable that I've given is W, I'm going to call this V in terms of W because I'm using W as my variable. And then I'm just going to do the length times the width times the height. Now when you're doing this in a calculator, you don't need to worry about multiplying it out. You can just put it in your calculator exactly like that, except you're going to have to put X, of course, instead of W. Then, just like we've done in the past units, we're going to find the window that best fits our data. And we're going to think about, if we're talking about a box, can we possibly have negative widths and lengths or heights? No, so we know it's not going to be negative. So we can actually make our graph that we're going to end up having just in one quadrant. So I'm going to draw my graph. And I just need one quadrant. And realize that part of the reason I like to write my notation like this is because now V depends on W. So down here, this is going to be the width in inches. And then over here, the volume in inches cubed. So I went and put it in my calculator, and then I changed my window until I found something that worked. And once I could see that maximum, I decided to count by 5s along my width. So I put 5, 10, 15, up to 20. And then I counted by thousands up to 5,000 on my Y. So I put 1,000, 2,000, 3,000, 4,000, and 5,000. Then I want to find that maximum point, so I went and put it in and went to the left and the right, and I found out that my maximum point came out to be 8 point. So I'm going to go do it one more time. Second trace, and I go to maximum, and then I go to the left, and then I go to the right, and I ended up with 8.889, 8.889, and for the Y it was 4,213.992. So I'm going to plot this point now. So this point is going to be about here. And then the other point I need to know is my 0. So again, I'm going to go to second trace 0 and go to the left and go to the right. And it's at 13. So I'm going to put a point here and label it 13, 0. And then I'm just going to draw my graph here. Now this is actually a cubic graph, but I don't need the whole cubic. Okay, all I need is the part that's here in the first quadrant so that I can find this maximum point, because that was my goal. That's what they asked me for if I look back at the question. So what is the maximum volume? Remember, when they're asking what is, they're asking the y, so what's the highest value? So for the max volume, I'm going to record the highest y value, which is 4,213.992 inches cubed. But that's not the only thing they asked for, is it? They also asked me for the dimensions. And remember, dimensions means they want me to find the length, width, and height of my box. Now, I already know from my point here that this right here, what is this x standing for? It's standing for the width. So I already know what my width is. It's 8.889 inches. Now, how am I going to find my length? Well, I go back to my picture and I remember the length was 2 times w. So I'm going to do 2 times 8.889, and I get 17.778. And again, it's in inches. Then I go back to recall what my height was, and it's 80 minus 6 times 8.889. So it'll come out to be 26.666 inches. So basically, it's kind of like the quadratic problems that we've done earlier. You're just going to put in you're going to first of all start by drawing yourself a picture to figure out what's going on. Okay, then you're going to label your length, width, and your height. Then you're going to write your function. Then you're going to graph it to find the maximum value. And then you're going to go back and use that information to plug it in and find the length, width, and the height. So let's look at another example. We're going to actually extend the problem you did in class. Okay, in class you made a box with no lid. Now we're going to think about, what if I wanted to make that same box, but this time I wanted to make a lid. So I'm going to start by drawing myself a picture. And a lot of times it helps to draw the picture because we know that I'm going to make a box that's going to have a lid. Okay, so I'm still going to end up with a box over here. Okay, that's going to end up being like this, and it's going to have a lid on it. Okay, so right now I'm not sure what the length, width, and the height are, except that I know that if I I'm going to cut out the squares over here so that I can fold up that side. And this is going to be x, and this is x. So I know that my height is going to be x. So that part I can label. Now, how am I going to make a lid? Well, I'm going to go halfway in between here, and I'm going to make this top half over here the lid. And so I'm going to end up having to make a fold here. And since I'm folding these up, I'm going to actually cut off a rectangle here and a rectangle down here. So remember what the cardstock was to start with. It was 11 inches by 8.5 inches. So, all right, we can stop having interruptions. Now I want to figure out what this length is right here. So since this is the halfway point in between here, I'm going to do 11 divided by 2. So this is going to be 5.5. But notice that I'm cutting out this x here. Okay, so this is going to be 5.5 minus x. And then on this side, I'm trying to figure out what this side is. It's 8.5. So I'm going to end up taking 8.5 minus, dividing it by 2 as well. So it's going to be 4.25. And notice on this side, I'm taking out 2 x's. So I've got to put minus 2x. So to get the equation for my volume, now notice this time my x is going to be my height, right? So I'm doing it in terms of height. But I'm still going to find the volume the same way. It'll be 5.5 minus x times 4.25 minus 2x times x. And then I could go plug this in and find my maximum just like I did on the last question. So the tricky part is, how do you figure out what your length, width, and height is? So you need to start off by drawing yourself a picture. Sometimes it helps if you draw, it helps to draw, before you cut it. Okay, on this problem I think it made more sense for me to figure out what was going on if I thought about how I was cutting it out and the fact that this half of the paper was going to actually be making my lid. Okay, then this half of the paper was making my base. And then I had to realize that only on one side I was taking away just one x, whereas on the other side I was taking away two x's. So on all of these problems, that's what you're going to do. You're going to have to figure out what your length, width, and height is so that you can then write your function, then you can graph it, and find the maximum point.